Yes?
Okay, so like, what's that called? The round thing instead of the square thing. Shoot. The bracket. Yep. Bracket.
Bracket instead of the parentheses. Okay, yeah.
How do you,
That's all right. How do you what?
know that you put it by the zero?
Because the thing is, this is asking about increasing and decreasing, right? If I look at 0, is this thing increasing at 0? Is it decreasing at 0? So since it's doing neither of those things, it's parentheses. And honestly, for intervals, it'll pretty much always be like that. If you're using the interval notation, it's just always going to be... Any other questions? Okay, that's the squaring function. Logically, what's next? Cubing function. Now, they don't usually go beyond that because a quartic function looks... The parent function of a quartic looks almost exactly the same as a parabola anyway. So they usually just stop after the cubic and do some other odd ones. Cubing function, what's the most basic cubic function look like if I graph it? The black one up there? Not quite. It's close. The thing is, if you actually graph it in your calculator, it looks more like this. It's like an elongated S. It doesn't have that part where it has a relative max and a relative min. Okay, it just kind of sweeps up and goes through the origin there. What would the domain of this be? All reals. Range? All reals. Intercepts? The origin. Symmetries? Yeah, 180 degree rotational. So 180 degrees around the origin. And when's it increasing? From where to where? What? Negative infinity to infinity. This thing is always increasing if you look at it. Because if I go from left to right, it's going up, it's going up, it's going up, it's still going up, it's still going up, it's still going up. It's behaving a little bit odd. It looks a little bit odd because it's what's called concave down followed by concave up. But it's still increasing the whole time. Square root function. What's square root look like? Yeah, it's kind of like half a parabola, sort of, opening to the horizontally. That's the way I think of it anyway. It's technically not, but it looks like it. Yeah, so it just looks roughly like that. What would the domain of this function be? Zero to infinity. Domain and range, I don't always do the interval notation, though. I usually do the other, but you can if you do. It's nothing wrong with that. So this is all real numbers such that x is greater than or equal to 0. Honestly, there's a lot of different ways you can state these answers. I'm trying to show you all of them because you will see them different versions come up. This is, again, where you could do all non-negative reals. That's the way the book answers it in this section, is all non-negative reals. What about the range? Yeah, it's at all non-negative. It's the same as the previous one. The only difference is, since it's range, it's y. Yeah, instead of x, it's y. Looks way too much like a z. Intercepts. Origin. You can still do the square root of 0, so that's still an intercept. When is this thing increasing? 0 to infinity. They say use parentheses. That's one where I'd argue you might be able to make an argument for brackets since it's not doing anything to the left, but they still use a parentheses for that when you're talking about increasing, decreasing for that one. Okay? Be good so far? Okay. Next up, the one people forget what it looks like. 1 over x. Reciprocal function. Anybody remember? Yeah, kind of like that. The idea is it's only in 2 quadrants. It's in the first quadrant and the third quadrant. What's the name of the shape? Yeah, it's a type of hyperbola. Okay, what would the domain of that function be? All reals except 0. So I'm going to write that as real numbers such that x cannot be 0. So all reals except 0. What about the range? Same? Oh, okay. Intercepts. None. There aren't any. Symmetries. Say again? Yep. 180 degrees around the origin. When is this thing increasing? What? Yeah, never. It's always decreasing, except for when? So how would I write that? It's decreasing over what intervals? What? Anybody? From negative infinity to 0? And again from 0 to infinity. So it's decreasing over that interval. Everything but 0. Okay. A little bit of an odd one. Not really. This section's pretty straightforward. Step functions, also known as greatest integer function, also known as floor function. What's it look like? It's the stair one. Yep. Everybody vaguely remember this thing? Usually it gets touched on once and then you don't do anything with it.
No. I've never seen this.
Never?
I've never seen this graph.
What?
What is this graph? How do I do that?
On your graphing calculator. What class do you have last year?
Plus. The plus.
Plus? Okay. Honestly, the plus with the accelerated pace, this is something you don't use very often, so they might have skipped over it. It's possible.
They did.
So, on your calculator, this is on there. If you hit math, the first thing you see is ABS. What's that stand for? Absolute value. If you go down to I think it's 4th or 5th where it says INT, that stands for greatest integer function. Okay? That will actually, if you do y equals and then put INT with an x in there, so hit math, 5th one down, it'll generate the stair step. So, looking at the graph, what would the domain of it be?
Whoa.
What? All real numbers. The domain is still all reals because if you look at it, wherever you have an open circle, above it somewhere you have a filled in circle. Okay, and the bad part about doing it on the graphic calculator, you don't get those circles.
That's awesome though.
Range.
I have no idea.
All integers. Anybody remember the letter for integers that I had last year? It's the Z.
It's a Z with the extra line.
Yep, double struct Z. The problem is you have imaginary numbers with I.
Yeah.
You also have irrationals. Yeah, so they do Z.
Why the double struck thing?
The double struct thing?
Yeah.
It's how you do a bold letter on a chalkboard, so you don't waste a whole lot of chalk. That's where that comes from. It's technically just a bold R and a bold Z. You see that in college textbooks, but writing-wise, people do it like that, so I don't have to shade and try to show a bold Z with chalk. Intercepts. What's the y-intercept? Yep, the origin. What's the x-intercept?
There's a lot of them.
There's a lot of them. There's actually an infinite number of them, but from 0 to 1. So you can write that a couple different ways.